Hello friends, welcome to Laptex. My name is Nasir and today we have a HP 15 model and the part number is U81 and it seems that the water spill on this board or water spill on the laptop and that is why lots of problem has been created in this motherboard. Today I will demonstrate you the process of diagnosing motherboard ranging from the DC in to the last, how you diagnose the motherboard, how you repair the motherboard. This thing we will learn today. Now let's come and see the part number of this motherboard. So now you can see the part number of this motherboard, DA0U81MB6C0 revision C. So it is it comes with i3 or i5 third generation processor and it is without graphic. As you can see that the graphic chip is not embedded in the motherboard. However, the same model comes with the graphic chip as well, and there must be SLJ8E, there would be HM76 SLJ8E and DDR3 RAM module. Now let me inject the power in this motherboard and we will see that what is the actual condition of this board. Now let me inject the power. Here we must get some light. So now you can see the amperage, it is taking very good, but no light appears on the DC jack. So it indicates that something load it is taking. The amperage, you can see that it is load taking, but we are not getting the light indication that indicate that we are not getting 3.3 volt LDO on the IO side. So maybe the problem, if we without diagnosing, if somebody asks me that what could be the reason, we can say that there is a 3.3 volt missing from the 3.3 and 5 volt regulator. There might be issue of the EC BIOS, there might be issue of your controller IO, and the might be problem in the RTC section. But that is the only hit and try method. How you diagnose these types of motherboard, you just see how we repair these types of board. As we have discussed earlier that this motherboard I have received with the lots of corrosion in the motherboard. You can see here the water marking. I have cleaned this, but despite there is a corrosion mark, you can see on this area, on the core area as well. Okay, and I have to change the LVDS connector because now you can see so many corrosion is on this pin, and the pin is removed from here. So I need to, at last, if the display comes in the keyboard, then I need to change it as well. So there was the lots of the water marking on the nearby the charging IC, and I have cleaned it and I just check it. The situation is constant on this point 0.18. So let me check the condition of the DC supply. Let me begin it from the beginning. So here is the P channel MOSFET and this is the N channel MOSFET. As let me show you in the schematic, as well as I have the board view of the same model. Now you can see here, let me show you the board view. This is the board view of U81 model. As you can see, this is the U20, this is the processor, and this is the graphic chip. However, there is no graphic chip in this motherboard, and U15 is the controller IO, and this is the PCH. Okay, so I have to start it with the DC connector. So it is the connector 12, and I have to begin it checking from this point, and then I will move forward. And this is the schematic. What I have to target here, I have to search the DC in supply where it is going to. So I have to write here the CN12. So let's find out CN12. CN12 is the DC connector. Now you can see this is the my area. I have to begin from this point. So first of all, what I need to check here that as soon as I connect the DC into this jack, then after this coil the voltage will transmit into the VA, and then it will pass through this. This is the transistor divider. This is the transistor divider, and also you can use on behalf of this transistor divider you can use a voltage divider of the resistor. And the more details of the replacing this transistor divider into the voltage divider with the help of two resistor we have discussed in our video class of DC in section. You can take benefit of that video also. So this will pass and it will transmit into the VAD voltage, and then the matter starts of the problem. So usually we are experienced of this problem that we usually do not get voltage transmit from the VAD to SRC supply or DC in supply. So you can see the name of the power SRC. This is the power source. This is the main voltage which leads all the voltages into the motherboard. So this is the mother voltage of any motherboard. Anyhow, I need to transmit this voltage into this portion. This after this sensing resistance, if you get the voltage, then you can expect your motherboard is getting 19 volt, and that will occur just due to this AC drive voltage. And how AC drive voltage start functioning? When all the charging IC requirements is accomplished, then you can say that your AC drive is produced by this charging IC. This thing we have discussed in our theoretical class in our video session. If you have watched that video, then you would understand very easily what is the role of ILIM, input current charge monitoring, and IOT, and each and everything, how you can check the voltage into current form, how you can calculate the current into the voltage form. Everything we have discussed in detail. So that is the 12 hours video of the particular charging section. So you can get benefit of that video by contacting on the given number. So let's move forward. This is the generic case study I am just bringing forth to you to improve your knowledge. So let's come and check from the beginning. Do I get on the drain side of the PQ36? So let me find out on the board view. PQ38, I think it was wrong. PQ36, it is PQ36, sorry for that. It is PQ36. It is the 36 located here. So here are, you can see that it is not showing you the entire pins. It is showing you 1 2 3 4 5. It is not showing you. However, you have to matter only 1 2 3 is the source, and 4 number is the gate, and 8 5 8 6 7 is drain. So first we need to check the drain side. So this is the drain side. You can see on the board. Do I get the voltage on the drain side? So now you can see on the multimeter as much voltage I am injecting. Okay, now you see 20.0 volt I am injecting here, and some voltages are just because of the lead section. So 20 volt we are getting on this point. Now what is the thing required here? If you calculate, if you see in the schematic, here we need to get 16 to 17 volt you need to get on the gate. So let's check the gate area. Now I am checking the gate area. So here is the gate section. Now you can see that 18.545, it is almost right, and we are getting the, because that is the working as a diode mod, because here if you want to calculate this BJT divider, you need to apply KCL and KVL law, then you would be able to calculate this area. Otherwise you can use here a voltage divider as we have discussed in our video classes. So it is up to you how do you want to calculate it. Here we need at least 17 to 18 volt, and which is quite enough to charge the battery. So this function is required when you are injecting the battery into the motherboard. It is playing very vital role as per the current sense. because if the much current goes out from this MOSFET, then that could be reason to misbehave the charging. So here this is very important point in the matter of charging section. So let's move forward. Since we are not getting the voltage on this particular point, so I have to generate the voltage at anyhow. So now let's move forward. The voltage reached on the PQ37. So let's check the PQ37 where it is. So I think I would be able to see here. Now you can see PQ37 is here, and it will reach on the PQ38 drain side. So let's check, it is the drain side as it is showing me on the board view. Now this point from drain to source on the PQ36, and after this diode, this Zener diode, it reached on the PQ37 on this point, and this is the gate where we are expected here, since it is the N channel, here we are expecting 24 volt if it is the gate. So now let me check what is this. This is the power SRC pin. Now you can see this is the power SRC pin where the actual voltage is required at 19 volt. After switching from 3 number to 2 number, if this voltage is generated just because of this 24 volt, and this 24 volt is coming from charging IC, so I think this is not generated on our multimeter. Now you can see here, so I am checking the gate, so there is no voltage on the on this N channel MOSFET, and if your switching is not clear, then I would like to recommend you to watch our switching video, where we have described all the switching materials, like how diode is switched, how a BJT is switched, how does it function, how MOSFET is switched, operational amplifier, working principle, and gates we have discussed over there. So each and everything has been covered over on that particular single video. So we have described over there the theory as well as practical, so that would be very much beneficial. How does it functions, because this is the basic concept of laptop repairing or desktop repairing or mobile repairing. So if your basic is not clear, so don't move forward, you just complete this video and you just beef up this particular section, and then you move forward. Now here we are not getting voltage, so we cannot expect in the motherboard any voltage, any 19 volt in the motherboard. Now you can see that this is the area where I am expected to get 19 volt, because 3.3 and 5 volt start to work. When this regulator, particular 3.3 and 5 volt regulator, start to getting 19 volt in the regulator, then it will release LDO voltage and S5 voltage or suspend voltage as per requirement. Now what I need to do here, I have to check, as I told you that I have to check the requirement of the charging section. So let's begin. However, as I told you, it is impossible to describe each and everything here, because as I have mentioned here, the only charging video is we have made, that is the 12-hour video of single charging section, where we have described each and every pins, where we have described internal logic of the particular charging IC. So every charging IC internal logic is almost same. If you know only one charging IC internal logic, then you would be able to crack all the nuts, like any types of problem if you face, you would be able to rectify the problem. Now let's begin. As much the signal is required to check this types of problem, I would show you surely, because you comment on our channel very good, and we love you a lot. So that is why this is my prime duty to demonstrate you these types of video in order to update you. Now let's come and see what we are getting. First of all, I have to check here that the DC in supply is entering in this particular charging IC or not. So it is the pin number 20. So let me see on the board view where is the charging IC, and let me show you. This is the charging IC PU1, and I have to target the pin number 20, and across this PR6 it is coming, and that would be around 10 ohm resistor. Now you see that would be around now you can 22 ohm. So it vary in the different motherboard, so you have not to mug up that always you will get the 22 ohm resistor. Sometime it is 10 ohm, sometime it is 2R2, sometime 3R3, sometime 22 ohm as well, but maximum I have seen not more than 50 ohm. So you have to also check this one if the battery charging problem you are facing. So now come and check. So here we are checking 22 ohm resistor. Now we are getting 20 volt and inside as well as outside. So it is the inside and now it is the charging IC side, we are getting 20 volt. So our 20 volt entry is okay. Let's do one thing, let's switch it off and keep it on the beep sound, and you have to make it sure that whether it is giving the right value or not. So 22 ohm we are getting, so that is absolutely right. Now let's move forward, turn it on once again. I have injected the DC power supply, but despite nothing is happening. Now we have found that our 19 volt entry into the charging IC is perfect, and there is no problem at all. Now let's move forward and check the next signal. Next signal is in charging IC is AC in, and which is also a part of the DC in ratio proportion. AC in or AC detect is the same thing, where you can calculate. We have asked this question, this is our favorite thing which we have asked in our question session when we were conducting the quiz session. Then we have asked this question that how can you identify that what voltage you will get if your AV air is not present, and in case if it is present. So there were the two questions. If it was not present, then what would be the voltage you will get on this point, and what voltage you will get if VA voltage is not present. Vice versa, you can also comment on our comment box that what voltage you are going to get if VA air is not present. Let me show you what is the VA voltage. This is the VA adapter air is the VA voltage, and now you can see that VA and VA air is coming here. So in both case you have to comment on the comment box that what you are going to get in this point. How do you calculate? I would like to see you. I will appreciate you if you answer the right answer, because you also confront these types of problem. You also have to diagnose that what should be on the pin number 6. So now let's come and check on the pin number 6. So here is the pin number 1. So 1 to 6, I think it would be here. Now let me set it on the voltage mode. So it is 2.8. I can say it is the right, but you have to tell the process how it is right. Okay. So now let's move forward and check the next output, which is the AC drive. So now let's move the next signal. This is the AC present, AC OK also it is called, and later on the name is converted into the AC in, which reach to the SIO section and tells that the DC in section is all right. So let's check the pin number 5. Let's check it on the pin number 5. So now we are not getting the AC OK signal on this charging IC. So can you tell me that what is the logic of AC OK? Because since it is the open drain, it must be getting voltage from somewhere, and now you can see on the, I told you that I will tell you the actual problem in this motherboard. I will not hide anything because I love you a lot. Now you can see here that region is pull up. Before changing this charging IC, you need to check the region voltage, which is the LDO inside the charging IC, and which will generate 6 volt on the pin number 16. So now first of all let's check pin number 16. Look, you can change and you can get solution, but you cannot know that what is the actual root cause of the problem which allowing you to change this IC. The day when you find this thing, that this is the reason causing the problem, then only you would be a perfect technician. So let's check the pin number 16. So 5, 10, 15, and this is the 16. Now see here, Let me show you a diagram, internal diagram of a charging IC. Now you can see that this is the condition. Let me show you so that you could easily understand. So any of the charging section, let me take and let me write a region, REG. I think after this I will get. Now you can see here that I have opened a BQ24707 internal logic concept, and here let me show you that 6 volt linear regulator supplied for VCC. So this is the LDO section which is coming out from the charging IC if the charging IC is good. Here one situation could be take place, like if the capacitor is leaky or open, that could be reason to reduce the voltage on the section. So here these are the signals which you have to understand if you want to crack the charging section problem, like AC direct, AC in, AC OK, ACP, and boost up voltage, and comp in, comp out, and I fault, IL, IM, I out. There are the so many calculations. So we have described each and everything, especially this thing we have described with the very best manner, how you calculate and what is the chances of charging your battery, how these signals play important role, and we have described each and everything functioning in, like how you will get this voltage, and what is the 20x and how you calculate it. There's so many things we have described, and especially this is the charging controlling section, and how controlling section function, what the voltage you should get on this comp in, and what should be the voltage on the comp out, how you can calculate what is the upper limit and the lower limit of IL, IM, and what is the I ought you will get. This is all about the calculation. This is not something you can mug up, because different charging IC has the different types of calculation. We have described each and every calculation, like there are the 16 to 17 comparator is given. Each and every comparator we have discussed in our charging section. So you can get advantage of that particular video. If you are weak in the charging section, you can have only this particular video with a very very nominal amount. So you can contact on the given number for this charging section video. So I hope if you are required, then you will contact us. So let's move forward, and let me focus on that point, what we are getting on this pin number 16. So we are not getting appropriate voltage on this point, because as I have shown you that there must be 6 volt. Even if it is 5.99 volt, that is not okay. That must be 6 volt. If it is going less to the 6 volt, check it with the DSO. If DSO is also showing you less than 6 volt, then you have to replace the charging IC. Only solution is remaining to change the charging IC if you are getting any bit of less voltage than 6 volt. So I think in this the capacitor is okay, then I have to replace the charging IC. Now let me change this IC and check it, the voltage that what we get on this pin number 16. So I have this charging IC. So there are so many ICs I have using on in front of me, just because this is the frequent board which comes to me. Let me remove it from the motherboard, because this is the case which I have cleaned only, and I haven't used here any new ICs. I thought that by cleaning I will got this motherboard okay. I thought that by cleaning this motherboard I will get this motherboard okay, but unfortunately the IC is gone faulty. So I have replaced the IC, and this IC is not new, it is taken out from the other motherboard. So let's check that does it function, or need I to replace with the new one. So let me fix it properly, because some area are not connected together. You have to mind by replacing the IC that two pins should not be connected together, and each and every pin individually should be connected on its place. Now let me clean it, and you will see what is the situation. Now you see here, I think everything is fine. If still I need to do something, I will use my soldering iron to fix the IC. Let me check it once again. So I think it is very perfect. One thing I have any suspicion in this motherboard, and this is the pin. You can say this is the pin 5, 5, 5, 15, 16, 17. 17 number pin. I have suspicion because I have scratched over there, and I have to check the connectivity. (15, 16, 17). So there is a connectivity. I thought that it is missing, the track is missing. So I think everything is okay now. Now let me inject the power. Now you see the light started. Now the situation, due to that I replaced this IC. Let me show you the value. Now you check, it is 6 volt. Okay, now you see that I turn it on, and actual condition, this thing you would understand that after taking the load of 0.030 amp, it is taking the load and it is going down. What does it indicate? It indicates that your motherboard started into the suspend form. If it support the suspend logic, then you will always see that ampere goes down to 0.010, 0.015 maximum. I have seen that 0.15, that is the maximum load. If it is taking much, then we can expect there is somewhere shorting in the motherboard. So this is also one experience which we have discussed in our theoretical class. So this indicating me that 19 volt is completed in the motherboard, has entered in the motherboard, and it has generated the LDO at least. So let's check it on the multimeter, that on the gate 24 volt we were expecting, so it is the 26 volt, because it must be greater than some value. So this value we will discuss in our video class. Okay, it is 26 volt. If I reduce the voltage, you will see that it would be 24 volt. Now you can see it is 24 volt. So how does it function? We have discussed with a detail in our video class. And what should be the right value on the gate of this N channel? You have to very careful at the time when you are checking the gate voltage. So this is a very big logic. There are the very big logic. We cannot discuss you here because it could mislead you. So this is the only thing I am telling you. There must be a higher voltage to the source and higher voltage to the drain. So now, the only thing I can describe you here, that the value on the voltage on the gate must be greater to the source and to the drain, because the 12-hour charging video I cannot describe you in a minute. However, you can see that the video is going so much long, so I just don't want to waste your time. So I understand the importance of your time. So let me tell you the crux thing, that do we get the 19 volt in the board? Now you can see that 18 volt I am injecting, and the same voltage I am getting on the motherboard. Now let me check the switch voltage. So this is the on off switch. So now let me turn it on. So you see something that I am turning on, and fan spins and off. Now you see fan spins and off. And what is the current load it is taking? Now you see it is going 0.50 and it is dropping down. So what is happening here? This only happened just because no voltage, there are some voltage in the motherboard which is unable to be constant on the same place, like RAM voltage 1.05 volt, VCC SA, VCC P voltage, and 1.8 voltage, and core voltage. There are so many voltages, like voltage agent is not stagnant in a place. If it is unstable, then SLP S3 will be drawn back to the PCH, so that could cause to shut down or off your system. So also load switch is something in the motherboard which could cause to pull back your SLP S3 signal, and also the same reason you will get laptop will on and immediately off. And one important thing in this motherboard, this is the green clock, and we have described in our video class what is the clocks, like blue clocks, green clocks, and ICC table, like which is the embedded clock inside the PCH. We have described each and everything, all the communications we have covered over there. That would be very much beneficial to you if you are really a lover of electronics, and if you are really lover of laptop repairing, then this video would be very much helpful to you. Now what is the reason to solve? So guys, as you have seen that the problem what now we are facing here, so it seems that the more complicated it is going on. Earlier it was not generating 19 volt. I have done this problem, and after that I am facing this problem that laptop is turning on and off suddenly. Now you see that fan spins and off. So I think the video would go more longer, because after solving this problem, even I have to change this particular connector, so it will take much longer. So I think this is enough for you as of now. So inshallah in next video I will show you that what is the solution of this particular problem when laptop is turning on and off. So guys, I hope that you have enjoyed this video, and in this way we face daily these types of challenging problem, and we carry this out very easily, because our concept is very different, and we also follow the concept, and we also offer you to follow the same concept. You will quickly solve the problem. It doesn't matter, you also repair the laptop the good manner, but only the thing you will get from us, you will save your time, because we hit on that particular point where there is a problem. We do not on our hot gun unless we are sure that we are going to get some output from the motherboard. We are going to get output, some positive feedback on the motherboard. Recklessly we do not work, and the same thing we suggest. If you don't follow, even if I do not follow the same rule, we also stuck up somewhere. So the same, if you follow, then inshallah you will be a very perfect in laptop repairing. And you can see the so many comments. So we have very limited time, we cannot help you a lot, because we have to work as well. If you ask for that laptop is not getting charged, so it is not possible for us to tell you on the message, because as I have told you that this particular charging IC we have described in 12 hours. So can you imagine that 12-hour content could be explained in a 5 or 10 minutes? Not at all. So that is why that is not very much big amount. If you want to take that video from us, you can contact on the given number, and you can buy a particular videos where you have the problem, like DSO video, like communication video between IO and PCH, like CRO video, like BIOS, how to check the BIOS, how to clean the CSME, how to clean the TXC region. So there are the various amount of sections we have made. You can contact us for the particular section as well, and if you want to take the all, you can also contact for the entire section. So I hope guys you have enjoyed this. So guys, if you really love this video, please like our video and share in your local groups, and if you haven't subscribed our channel, please subscribe it, and also hit the bell icon button so that you will get notifications from our channels. Thank you guys, thank you for watching this video.